Welcome to the Explainer. Today, we are talking about a seriously powerful tool for big data, Apache Spark. Look, if you've worked with data, you know that having the right engine is everything. We're going to unpack Spark's unique all-in-one approach and really see what makes it such a game changer.
All right, so let's start with a scenario that I bet a lot of you have run into. You're totally comfortable with SQL, right? You know your relational database inside out. But then, the data just gets too big. Or maybe it gets too complex. It's not just neat rows and columns anymore. You're dealing with logs, live streams, you name it. And suddenly, that database you rely on starts to creak and groan. So, what do you do next?
So here's how we're going to break it down. First, we'll ask, why even look beyond our good old databases? Then we'll get into the heart of Spark, its core. After that, we'll see how Spark SQL makes things easy, check out the other cool components it has, and then, the big finish, we'll see why having a unified engine is such a big deal.
Okay, first things first. Why do we need to look past the tools that have honestly served us really well for a very long time?
Well, the simple answer is that data itself has just changed. Modern data pipelines aren't doing just one thing anymore. Think about it. You might need to process a massive batch of old data, then run some quick interactive queries on it, and analyze a live stream of new data as it comes in, and maybe train a machine learning model on top of all of that. You see, it's all connected. And in the old days, that meant duct taping like 4 or 5 completely separate, complex systems together. It was a total nightmare to build and to keep running.
And that right there is the exact problem Spark was built to solve. It all starts with its foundation, which is called Spark Core. This is the engine that makes literally everything else possible.
Okay, so the most fundamental idea in Spark is something called an RDD. That stands for Resilient Distributed Dataset. I know it sounds a little intimidating, but the concept behind it is actually pretty simple. Just picture it as your data, right? But it's a collection that's been cleverly chopped up into little pieces and spread out across a whole bunch of different computers. And because it's all spread out, you can process all those pieces at the same time, in parallel. And that's what makes it so mind-blowingly fast.
Now, what's really cool is how this actually works. Every single Spark application follows this same basic flow. You start with some data, and you create an RDD from it. Then you tell Spark all the things you want to do to it. These are called transformations, like filtering out bad data or something. You can even tell it to hang on to an intermediate result for later. But here's the kicker. Nothing actually happens yet. Spark just remembers your instructions. It's not until you call an action, like, hey, count the results or save this to a file, that the computation actually kicks off. This lazy way of doing things is super smart, because it lets Spark figure out the most efficient way to run your entire job before it does any real work.
Okay, so RDDs are clearly powerful, but let's be real. What if you're not a programmer who wants to be writing all these transformations and actions? What if you just want to, run a SQL query? Well, for anyone with a database background, this is where the magic really begins. Let me introduce you to Spark SQL.
So Spark SQL is basically a module that sits right on top of Spark Core, and it does exactly what it sounds like. It lets you work with structured data using the language you already know and probably love, SQL. But, and this is the important part, behind the scenes, your simple SQL query is being run by that incredibly powerful distributed engine we just talked about. So you get the ease of SQL, but with the insane scalability of Spark. Best of both worlds.
And this right here, this shows you the real power move. On the left, you've got your standard SQL query. We've all written that 1,000 times. Simple, familiar. But look at the right. In the Spark world, you can run that exact same query, but the result you get back isn't just a static table. It's a live object that you can keep working with using code. You can just seamlessly blend SQL with more complex programming, which lets you do types of analysis that are basically impossible if you're stuck in a pure SQL world.
All right, but it doesn't stop there. Let's move up to the next level, because Spark is so much more than just a way to run SQL queries really fast.
So, what if your data isn't just sitting there in a file? What if it's pouring in real time? Like click data from a website or sensor readings from a factory. Well, for that, you have Spark Streaming. And what's so genius about this is the consistency. The code you write to process a live stream looks almost identical to the code you'd write for a batch job on historical data. That makes it super easy to use the same logic for both batch and real-time stuff.
Okay, what about machine learning? Say you need to find patterns or make predictions from all that data. That's where mllib comes in. It's Spark's built-in machine learning library. It's packed with all the common algorithms you'd expect.
for things like classification or recommendation engines or fraud detection. And the key thing is they were all built to run at massive scale, right there on the cluster. This means you can train a model on terabytes of data without having to copy it all over to some separate, specialized system.
And one more. What if your data is all about connections and relationships, like a social network or maybe tracing a package through a supply chain? For that kind of problem, there's graphx. It's a special library just for processing these graph structures. It lets you do really cool things like find the most influential person in a network or calculate the most efficient delivery route, all using the same Spark framework.
So, we've got SQL, we've got streaming, machine learning, and even graph processing. Each one of those is super powerful on its own, but usually these are all completely separate products from different companies. So here's the big question, the real aha moment. Why does it matter so much that Spark puts all of this into one single unified engine?
And this quote right here, it just nails it. The point isn't just to have all these capabilities, it's to make them work together without any friction. Because let's face it, real-world data pipelines are complicated. They need to combine different kinds of processing. A unified engine makes that kind of combination not just possible, but actually easy.
So let's really break down what that unification gets you. First off, if the core engine gets faster, everything gets faster. Your SQL queries, your streaming jobs, your ML models, they all get a speed boost. That's huge. Second, it's just way easier to manage. You're maintaining one system, not trying to juggle 5 different ones. But the real game changer is the third point. You can build one application that does things that used to be ridiculously hard. I mean, think about this. You could have a stream of live data coming in, use a machine learning model to score each event in real time, and then immediately serve up those results so an analyst can query them with SQL. That whole complex pipeline happens inside one single integrated application. That's the power.
So if you remember one thing, it's this. Spark isn't just a faster version of some old tool. It's a totally different way of thinking. It's one single, unified engine that can handle pretty much anything you throw at it, from basic batch processing in SQL all the way up to live streaming, machine learning, and graph analytics. The whole shebang. And that really just leaves us with one final thought. Take a second and think about the data challenges you're facing right now. Think about the data pipelines you've built, or the ones you wish you could build. How many different, separate systems are you cobbling together? Now ask yourself, how much simpler, faster, and just plain better could they be if they were all running on one unified engine?
And that's our look at Apache Spark's unified engine. Hey, if this helped you connect the dots, do us a favor and hit that like button, share it with someone who might find it useful, and definitely subscribe so you don't miss our next one. Thanks so much for watching.